So the next topic I want us to look at is called Amazon Simple Queue Service. And this service is actually the major service that we can use for turning a coupled application, a tightly coupled application, is the service that, okay, let me show you this back. Can you remember this this component the other time that they are connected with each other? So with the help of SQS, we can turn a tightly coupled application on this services is, this topic is not correct. Pardon me for that. It's supposed to be microservice with AWS SQS, not SNS topic. This is SQS. So with the help of the SQS, remember the architecture that we have initially is, let me go back to the initial diagram. This, you can see that they are just connected together, sending information, which is okay, but it's still, the communication can still break. So with the help of SQS, the SQS is actually going to sit in their middle. So any one of them that wants to communicate with each other, they will be sending the communication to SQS. The SQS is going to hold that communication for whoever that needs to respond to it. If component 1 wants to communicate with component 2, it's going to send the communication or the service that it wants to get done. It's going to send the, let us assume we want to process a service. Maybe it has collected user information, or let's say business logic. Business logic is a better option there here. Let's say here, business logic. Remember the server, which is the front end, the user has filled in some form with his credit card information. So is this credit card needs to go to the business logic for the business logic to review the credit card and actually see whether the user can actually use the credit card or not. So if it is only one credit card, then this component will not have issue. You can quickly process it. But now think of, there is thousands of credit cards that it needs to process. Then it might not be able to process all of them so fast. So in that situation, if we had to wait for it to process one before we give it another one, then the remaining customers will not be able to input their credit card. So that's why we have a SQS here in between them. So when the user fill in their credit card, it's going to be stored in the SQS. This is credit card 1, credit card 2, credit card 3, credit card 4. It's going to be stored in the SQS. So whenever the business logic component is ready, it just come to the SQS and pick one of the credit card, then go back, process it. When it's finished, then it deletes it from here. Then you go back second time, it pick the second one, it process it, and when it finish, it deletes it from here. So with this process, even if this component is not working, the SQS will still continue collecting the credit card. So the user will not even have any issue because the front end is working. They can still continue putting in their credit card. And if components, if the web server, if there is a delay that it cannot process the application, Then there is a time limit though, that this SQS will have to hold the credit card. And if it's not getting response from this, there is going to put it in another container. So all those ones we're going to discuss is under solution architect. But the main thing you need to understand here is that the SQS is now helping us to make sure two tightly coupled components are now loosely coupled components. So that is the purpose of the SQS. If I go back to our SQS, so when we get to the solution architect, we're going to see how two components can share resources without waiting for each other. They just push the component to the SQS, and SQS is going to be the one to like hold the component for the time being, and whenever the component that need it is ready, it's going to be requesting for that component. And once you finish processing it, it will delete it from the from SQS, so that another service or server will not pick the same components. All right, this is the end of the topic 6 under compute in the cloud. In our next topic, we are going to be looking at container services. You see that the only service we've been discussing on, we have discussed like almost 5 services now under we have discussed like 5 topics under container, under compute. We've discussed about EC2 instance, which is a server, or some people call it VM. We've discussed, and under this, there's a lot of small topics that we discussed, but the major topic is what I'm listing. We've discussed elastic load balancer, and we've discussed auto scaling and SNS and SQS. SNS and SQS, they are not specifically compute service, but we actually really need them in order to be, I'm just arranging them based on the topic that goes together. So these are compute, this is the main compute service, while all of these are helping the compute service. So another compute service that is very, very important for you to know is container. And in our next class, we're going to be talking about, I'm not going to be going deeply into Docker, Kubernetes, and the likes in this class, but I will be introducing you to Docker, just a brief. I will introduce you to Elastic Container Service. We introduce you to Elastic Container Registry, and Elastic Kubernetes Service. Then we have Lambda. All of these are just basic introduction without going deeply into them. You're going to have enough knowledge to understand what they mean and what they use for. So that's why I'm telling you guys that this cloud practitioner is not mainly for passing the cloud practitioner exam. With all this knowledge, you can actually build on it, use it to get a job, and also build on it for your for your solution architect. So I'm going to be stopping here for today. Before I stop, is there any question? Question.
Does time for Wednesday has it changed?
The what?
Wednesday time has it changed? Because
No, it's the same. It's the same. So the reason why we don't have class in last Friday is because I was on call at work and I posted it on the Telegram the day before that day that there won't be class on Wednesday because I was on call. And the service I was attending to was from 7 to 9, which is the time for the class. All right. Thank
Hello,
you,
sir.
guys.
Hello,
Yeah,
sir.
go ahead. Go ahead.
Yeah. Good evening. I'm sorry I came late. So please, I need clarification, or I don't know. So while I was practicing how to launch EC2 instance, I encountered some challenges, like so when I tried to connect my my server to the visual code, using the visual code, like I think I pasted the pictures on Telegram. So it was giving me connection timed out. So secondly, when I was attempting the assignments, the F1 instance, I couldn't find FPGA on Amazon Marketplace. So I'm kind of stuck.
So you should have posted that question on Telegram because somebody actually did it. So I don't know where you get it from. Maybe you have been able to help you. But if you go to Amazon FBA, you should be able to see it. Let me see. Yeah, I can. Can I stop the recording, or you want this to go on the recording too?
You can stop it.
Okay.